Here we have AP calculus AB problem. Okay, let's go to the question. Using a right Riemann sum with 4 subintervals, we have over here, what is the approximation of integral 1 to 3 1 over x times dx? Okay, here when I consider the integrand over here, that's a given function, that is f of x equals to 1 over x. And also, like the approximation of this integral can be written as integral 1 to 3. We have to approximate the value of this integral using a right Riemann sum of with 4 subintervals. So that is, let me write the stuff over here. That is equal to delta x times f of x1, positive f of x2, positive f of x3, positive f of x4. Okay, here I have taken 4 values for x, x1, x2, x3, x4 because we have 4 subintervals. That's why I have taken 4 x values and I have plugged in those x values into the given function f of x. Okay, here this delta x is the width of each subinterval. Okay, now let me draw a number line where I'm going to mark the given intervals. That is, the first value is going to be 1. Let me write over here 1, and here 1.5. Then we have 2, and here we have 2.5. Then here we have 3. Okay, let me erase the remaining part of the subinterval. Just a moment. 1 second. Let me erase it. Okay, so here I'll just mark the subintervals, the given subintervals over here. So 1, 2, 3, 4 subintervals. So for the first subinterval, the right end point is 1.5. For the second subinterval, the right end point is 2. For the third one, the right end point is 2.5. The fourth subinterval, the right end point is 3. So that is the value of this x1 is 1.5. So that is the right end point of the first subinterval, and x2 is this 2. The right hand point of the second interval, and x3 is 2.5 and x4 is just 3. And delta x is the width of each subinterval. So clearly the width of each subinterval is 0.5. Otherwise we can use a formula that is delta x equals to b negative a over n. So here b is the end value in the given subintervals, the right extreme value, that is 3 negative, the left and a is the left extreme value, that is 1 divided by n represents the number of subintervals. According to the information, 4 subintervals, it is n is 4. So then we get 3 negative 1 is 2, 2 divided by 4, which is equal to 0.5, the value of delta x is. Or the 0.5 can also be written as 1 over 2. Okay, anyways, since we find the fractions, when I go over the answer choices, we have a fraction as a result. So we can write the value of delta x as a fraction, that is 1 over 2. We can plug in 1 over 2 times f of x1 means f of the first, the right hand point of the first subinterval, that is 1.5. Let me do it over here. F of 1.5 positive, f of 2 positive, f of 2.5 positive, f of 3. Okay, now let me erase this stuff and continue the problem. Let me calculate the value of this f of 1.5. Let me do it. F of 1.5 equals to, already we know that f of x equals to 1 over x. That's integrand of the given integration. So if I want to get f of 1.5, I just have to plug in 1.5 for x over here. The same I have to do on the right side. Then I'm getting 1 over 1.5. Then I'm getting 1 over 1.5 can be written as 3 over 2. So then we can write this one numerator 1 as it is. When I change this division as multiplication, I have to get reciprocal for this 3 over 2. Then I'm getting 2 over 3. 1 times 2 over 3 is 2 over 3. Okay, now I got the value of this f of 1.5, that is 2 over 3. So now I can plug in 2 over 3 for f of 1.5. Let me do it. So 2 over 3. Now, so to calculate f of 2, what we have to do is I have to plug in 2 for x over here. Then I'm getting 1 over 2. And to calculate, let me calculate this one separately as I have done over here. F of 2.5 equals to 1 over 2.5. And we can write this 2.5 as 5 over 2. Then we have 1 times, that is, I'm writing this 1 as it is. I change this division as multiplication and take reciprocal of this 5 over 2. Then I'm getting 2 over 5. When I multiply 1 and 2 over 5, I'm getting 2 over 5. So the value of this f of 2.5 is 2 over 5. Let me plug in 2 over 5 for this f of 2.5. Let me write it. And to get f of 3, you just have to plug in 3 for x over here. Then I'm getting 1 over 3. Let me write it over here. Okay, now let me continue. Okay, now to add these two fractions, I need the common denominator. That is, we need to get the same denominator for all the 4 fractions over here. So for that, we have to find the least common multiple of this 3, 2, 5. Since the same 3 is repeated, we can ignore this. Let's find the least common multiple of the 3 different denominators, 3, 2, and 5. So is there any common divisor for all these 3 numbers other than 1? No, there is no common divisor. At least for two of these three numbers, is there any common divisor other than 1? No, there is no. So then to get the least common multiple, we have to multiply this 3, 2 and 5. 3 times 2 is 6, 6 times 5 is 30. So 30 is the least common multiple of the denominators we have over here. That is, we have to make each denominator over here as 30. Okay, let me do it 1 over 2 times. Okay, to make the first denominator 3 over here as 30, we have to multiply both numerator and denominator of the first fraction by 10. So when I do so, I am getting 20 over 30. And to get 30 as denominator over here in the second fraction, I have to multiply the second fraction by 15. Then I am getting 15 over 30. That is, I multiplied both numerator and denominator by 15. And now to make this denominator 5 as 30, I have to multiply both numerator and denominator by 6. Then I am getting 12 over 30. And here I have to multiply by 10. Then I am getting 10 over 30. Okay, now I got the same denominator for all the fractions. So now what I can do is I can take the common denominator 30. Now we have to add the numerators 20, 15, 12, 10. When I add this 20 and 15, I'm getting 35. 35 plus 12, 47. 47 plus 10, 57. Here both 57 and 30 have the greatest common divisor 3. That is, we can divide this 57 by 3. 3 goes into 57 19 times, and 3 goes into 30 10 times. So that's how the simplification we can do. Now we can multiply the numerator 1 and numerator 19. 1 times 19 is 19, and we can multiply the two denominators. 2 times 10 is 20. Okay, now I have approximated the value of this integration, that is integral 1 to 3 1 over x dx. Its value is 19 over 20, and we find 19 over 20 in answer choice D. The correct answer choice for this question is D.